Okay, let's unpack this. Welcome to AI Podcast. We're diving deep today into, well, the really intricate world of Waymo's self-driving algorithms. I'm Brian.
And I'm Kathy. We've gathered quite a bit of information to explore just how Waymo manages to integrate vision, LiDAR, and AI so effectively in their autonomous vehicles.
Exactly. Waymo, it grew out of that early Google self-driving car project back in 2009. They really do stand out as a leader in this space.
Definitely.
So our focus today is understanding that core innovation, how these three pieces, the cameras, the LiDAR, and the AI, how they actually work together.
Mm-hmm.
We also want to pin down what makes their systems so, well, robust
Mm-hmm.
and figure out where you can actually see these things operating now and, where they might be going next.
And it really is about that synergy, isn't it, between the sensors grabbing the data and the AI making sense of it all.
Absolutely. So the foundation, you could say, is this sensor fusion idea.
Exactly, that's what they call it. They don't just rely on one thing. They're blending data streams from cameras, LiDAR, and radar. It's key to how reliable it is.
Okay, so let's break that down. Cameras first. They're like the eyes, right? High-resolution images.
That's right. They're great for seeing things like traffic lights, signs, lane lines, people. They pick up color and detail really well.
And they work in different conditions, yeah, like day, night, some weather.
Pretty well, yeah. They've worked hard on that, capturing crucial visual details.
Then you've got LiDAR. That's the laser thing.
Light detection and ranging, yep. It sends out laser beams and builds this super precise 3D map of everything around the car, essential for knowing exactly where things are and tracking them.
And Waymo uses different types, short, medium, long range.
They do. That gives them both that wide view and the really fine detail up close and far away. It's quite a sophisticated setup compared to some others, especially for complex city driving.
Interesting. And the third one is radar, using radio waves.
Right. And radar's big advantage is in bad weather, heavy rain, fog. When cameras might struggle, radar can still reliably detect things, especially moving objects.
So it's like having multiple layers of perception.
Exactly. Complementary strengths. Each sensor type is good at some things, less good at others. By fusing the data, the AI gets a much richer, more reliable picture than any single sensor could provide.
And these aren't just off-the-shelf parts.
No. Waymo designs and builds its own sensors, specifically tailored for the demands of autonomous driving. It's a really integrated approach.
Okay, so the car's soaking up all this data. How does it actually understand what it's seeing? That's the perception system, right?
Spot on. Perception turns that raw sensor data into, well, a meaningful understanding of the world. It involves a few steps.
Like what?
First is object detection. Using AI models trained on just massive amounts of data to find and classify everything, cars, pedestrians, cyclists, cones, you name it.
And it gives them a confidence score, like how sure it is.
Yeah, and it tracks them over time. It's not just a snapshot, it's understanding the dynamics.
So not just, that's a car, but that's a car. Moving this fast, likely going there.
Precisely. Then there's semantic segmentation. Think of it like coloring in the picture.
Coloring in.
Yeah, the neural networks label everything. This patch is road, that sidewalk, that's a building. This detailed map of the environment structure is vital.
How so?
Well, if it knows that's a sidewalk, it can be much more confident about predicting where people might walk and, make sure it doesn't drive on it, even if the lines are faded.
Okay, got it. And then object tracking builds on that.
Right. It uses techniques like Kalman filters and deep learning to follow objects and predict where they're going to move next. It's about understanding motion.
And occupancy grids. That sounds technical.
It sort of is, but the idea is simple. The car builds this probability map around itself. Which spots are definitely occupied, which are definitely free, and which are uncertain.
Ah, like a constantly updating safe zone map.
Kind of. It's crucial for knowing exactly where the car is localization and for planning a safe path forward.
Okay, so it knows what's around it and where things are moving. But driving safely is also about predicting what others will do, right? The prediction system.
Absolutely critical. This part focuses entirely on forecasting behavior. What are those other cars, pedestrians, cyclists likely to do next?
And it uses deep learning models trained on all that real-world driving data.
Tons of it. But it's not just predicting based on current speed and direction. Context is key.
Contextual cues. Like what?
Traffic lights, stop signs, right-of-way rules, even subtle things like maybe a pedestrian glancing over their shoulder or a cyclist signaling.
So it's trying to understand intent.
Exactly. And the sources mentioned Waymo's gotten quite good at tricky situations, those edge cases.
Right.
Think unprotected left turns or people jaywalking unexpectedly. Those require really nuanced predictions.
Yeah, those are tough even for humans. Okay, so it perceives, it predicts. How does it decide what to do? Planning and decision making.
Right. This is where it figures out the best path. Starts high level, route planning, just like your GPS. Get from A to B.
Simple enough.
Then it gets more detailed. Behavioral planning, should I stop? Yield, merge now, change lanes, those kinds of tactical decisions.
And then the actual steering and speed.
That's motion planning. Calculating the exact, smooth, safe trajectory the car will follow, considering its own limits, acceleration, braking, turning circle, and importantly, passenger comfort.
You mentioned cost functions earlier. How do they fit in?
Think of it like a scoring system. The planner looks at different possible actions and assigns a cost based on various factors.
Like
Safety is usually weighted highest, but also legality, follow the rules. Efficiency, don't take forever. And comfort, avoid jerky movements. It balances all these to find the action with the lowest overall cost.
it's like optimizing the drive constantly.
In a way, yes. Choosing the best compromise between all those goals.
Okay, plan chosen. How does it actually do it? Control systems.
Yep. The control module takes that chosen trajectory and translates it into precise commands for the steering, throttle, and brakes, making tiny adjustments constantly to stay exactly on path.
And none of this works without amazing maps, I guess. High-definition maps and localization.
Absolutely fundamental. Waymo relies on these incredibly detailed 3D maps. We're talking centimeter-level accuracy for roads, curbs, signals, even trees.
Centimeter level, wow.
Yeah, and it uses clever techniques to know exactly where it is on that map, comparing its real-time LiDAR scans to the map data, using visual cues from the cameras. That precision is non-negotiable for safe city navigation.
So sensors, perception, prediction, planning, control, maps. It's intricate. And AI is the glue holding it all together.
You got it. AI is the brain, as the sources put it, trained on, as we said, over 20 million real-world miles, plus billions more in simulation. That training is everything.
Let's look at the AI models.
Yeah.
CNN's convolutional neural networks. They are for vision.
Primarily, yes, great for image recognition, finding objects in camera feeds, and that semantic segmentation we talked about, labeling the pixels.
And RNNs and transformers.
Yeah.
Recurrent neural networks.
Those excel at sequences, understanding things over time, so perfect for behavioral prediction, watching how things unfold and guessing what happens next. That temporal aspect is vital.
And reinforcement learning. That sounds like training through trial and error.
It is. Waymo uses it heavily in their simulator, CarCraft. They let the AI drive in challenging virtual scenarios and reward it for safe, efficient actions. It learns optimal strategies that way, sometimes even surprising ones.
So it learns by doing, but safely in simulation first.
Exactly. And they also use ensemble learning, combining multiple AI models for better accuracy and uncertainty modeling.
Uncertainty.
Yeah.
So the AI knows when it doesn't know.
Sort of, yeah. It can estimate its confidence. If it's unsure about something, it can react more cautiously, slow down, maybe wait longer. That's crucial for safety.
In CarCraft, the simulator seems really important for robustness.
Hugely important. They can test scenarios that are rare or dangerous in the real world. Construction zones, crazy weather, weird pedestrian actions, traffic anomalies.
Stuff you hope you don't see often.
Right. Training on both real and synthetic data makes the system much more prepared for the unexpected. It's how they handle such a wide range of situations.
Okay, so pulling it all together, how did Waymo get so robust? You mentioned 5 key things. First was sensor redundancy.
Yes, we touched on it, but it's worth stressing. Multiple sensors cover each critical task. Sun glare blinds a camera. LiDAR and radar are still working. That overlap is a core safety principle.
Makes sense. Second was the massive testing and validation.
Yep, those 20+ million real miles in places like Phoenix, SF, LA, but also rigorous closed-course testing for specific risky maneuvers.
And the billions of simulated miles.
Exactly, billions. That combination, real-world, closed-course simulation, gives them high confidence, especially for those tricky edge cases. Triangulated validation, they call it.
Third was the safety layer, the Guardian system. Like a backup driver.
Kind of, but it's an independent software system. It constantly watches the main planner and the sensors. If it spots imminent danger, like a pedestrian stepping out that the main system might miss or react too slowly to,
He takes over.
it can override the planner and hit the brakes hard, for instance. It's a critical failsafe. It's about proactive safety, not just reacting.
That sounds reassuring. Fourth was continual learning and updates. The fleet learns together.
Right. Every car sends back data on tricky situations. Waymo retrains its models with that new data and then pushes improved software out to the whole fleet over the air.
So they all get smarter together.
Constantly improving, it's a huge advantage.
And the fifth factor was redundant hardware. Physical backups.
Yes. For critical things like the computers, the brakes, the steering, there are backup systems. If one part fails, another takes over so the car can still stop safely.
It really is a multi-layered safety approach. So where can people actually use this technology? They're beyond just R&D now.
Oh, yeah. Phoenix, Arizona, especially Chandler and the metro area, that's their most established spot. First place, with fully driverless rides for the public via Waymo One.
Fully driverless means no safety driver inside.
Correct. Just you and the car. They cover a big chunk of the Phoenix area, Chandler, Tempe, Mesa, parts of Phoenix City.
And San Francisco. Much tougher city, I'd imagine.
For sure. Hills, dense traffic, loads of bikes and pedestrians. Waymo tested there extensively and now offers rider-only services in parts of SF, and they're expanding that to more public riders. It really sharpened their urban driving skills.
And LA is in the mix too.
Yep. Operating and testing in areas like Santa Monica and downtown LA. Again, complex intersections, heavy traffic. The goal is to launch the public service there after the pilot phase.
And Austin, Texas is the newest addition.
Just started pilot testing there recently. Texas generally has a more welcoming regulatory climate for AVs, and Austin's a big tech hub. Makes sense as a next step.
So they're quite strategic about where they go, looking at weather, demand, regulations.
Seems that way. They've mapped dozens of cities, apparently, but they prioritize based on those factors. Favorable conditions, ride-sharing demand, supportive rules.
Okay, let's talk about the business side. Waymo One is the public ride-hailing. What's the experience like for a user?
Pretty straightforward, like using Uber or Lyft. You use the Waymo app, request a ride, get an ETA and price, and a fully autonomous car picks you up. It runs 204/7 in their driverless zones.
And there's like a voice assistant inside.
Yeah, to help passengers if they have questions during the ride. It's designed to be seamless.
You mentioned Waymo via the trucking delivery thing is paused.
For now, yes. They put the brakes on the freight side, but their earlier work with UPS and JB Hunt showed the tech can apply beyond passengers. Maybe they'll revisit it later.
And the vehicles themselves. Started with Pacifica minivans, now electric Jaguars, even custom vehicles.
Right, they're using Jaguar I-Paces and working with OEMs like Volvo and Geely on integrating the tech, potentially into purpose-built AVs down the line. Partnerships are key.
With car makers, ride-hailing firms like Lyft and Uber pilots, cities.
All of the above, collaborating to integrate safely and effectively.
So summing up their business strategy, what are the key pillars?
Seems to be. 1, safety leadership building trust is paramount. 2, cost reduction making the tech cheaper, partly through their own custom hardware like LiDAR.
Makes sense.
3, a scalable software platform that can be updated and used on different vehicles. And 4, working proactively with regulators to shape sensible rules.
But it's not all smooth sailing. There are still challenges, criticisms.
Definitely. Scalability is a big one. They're still only in a few places. The cost per vehicle is still high. Public trust is fragile. Any incident gets huge attention.
Yeah, you see that in the news.
And the patchwork of state regulations makes expanding nationwide complicated. Plus, their cautious approach contrasts with some competitors who are moving faster, maybe taking more risks.
It's a balancing act. So to wrap up this deep dive, what are the big takeaways on Waymo's tech?
I'd say it's the masterful integration. Vision, LiDAR, radar, all working together, interpreted by really sophisticated AI. That synergy lets them perceive, predict, plan, and control effectively.
And the robustness comes from layers.
Exactly. Sensor redundancy, massive testing, real and virtual, the Guardian safety system, continuous fleet learning, and hardware backups. It's defense in depth.
And they're live in Phoenix, growing in SF and LA, starting in Austin.
A clear expansion path.
Yep, a careful, safety-focused rollout strategy.
Well, this has been incredibly fascinating, really getting under the hood of how Waymo works. Thanks so much for breaking it all down.
My pleasure. It's complex stuff.
It really is. And for you listening, as Waymo and others keep advancing this tech, What do you think is the biggest hurdle left for truly widespread adoption of fully autonomous vehicles, getting everyone comfortable and trusting them on the roads?
The big question. Definitely something to think about. We will be back next Monday with our usual weekly AI news. Until then, thanks for tuning in to AI Podcast.